hope you see my screen. Yep.
Yes, we can see it well.
Great. So today's agenda, let me introduce our colleagues, welcome our colleagues from 4Players. It's Philip, founder and CEO, and Marco, head of sales. We had a pleasure meeting on the AWE in Vienna in 2024. It was clear how curious and passionate about the technology is Marco, and about the people and all the support words that you said for Ukraine. It's we really appreciate that. Yep. And today we will talk about the proximity voice chat and the spatial audio and how your solutions can help with multiplayer experiences and especially in XR projects. So I think you'll share your screen now. Yeah, it's over to you.
Wow, how cute looks this. Very nice. Great. So we can start. Okay, great. Then let me introduce 4Players first, that you have a little overview about us, that you know where we are and where we're from, and after this introduction I would give the words to Philip. So 4Players is or was founded in the year 2000. We are based in Hamburg. It's on the north side of Germany, and at the moment we are around 30 employees. Most of them are developers. I take care of the sales part in our company, and 4Players is part of a bigger group. I don't know if you ever heard something of Golem, PC games hardware or something. These are at least here in Germany, Austria, and so on, quite famous magazines for gaming and PC things. So we are also a part of this group, and 4Players itself is expert in developing multiplayer tools, especially the last 25 years for dedicated game server hosting, but also in Odin, our voice chat technology. In the end, we are offering a whole platform. The idea behind Odin is that game developers get a lot of tools. So this is the server hosting. This will be the voice chat technology. In the future, we plan also to integrate matchmaking solution, anti-toxicity, and all this fine little things. And the idea is that game developers have an easy access and then fast access to these tools. Just go on this platform and activate if you have needs in this. We are working with different and many and different customers. It's not only the gaming sector, it's also non-gaming. So we are working, for example, with in the last 25 years with EA, with Ubisoft, with Funcom, for example, with many gaming studios like Combat Waffle. We are also in the non-gaming area. There we work together with, for example, BMW, also with the US Air Force, for example, but also with companies like the esports, in the esports area, like the ESL Faceit Group, for example. They're also using Odin voice. And that said, I hope I mentioned everything so far. I can give you a quick idea how spatial audio could be used in a gaming environmental and in a non-gaming environmental. So, for example, we have a studio called Madfinger Games. They have the game Gray Zone Warfare. It's some kind of first-person shooter. It's very realistic, tactical first-person shooter made in Unreal 5, and they are using, for example, Odin Voice for the proximity part to simulate realistic open world scenarios, and also as a radio communication for the squad teams itself. And to mention a non-gaming company, we could talk about BMW, for example. The engineering team is visualizing car models in VR. So these guys are having or presenting their new cars in VR and going, for example, around the cars or going inside the cars. And to communicate in a natural, realistic way, they are using Odin voice to make everything feel a bit more realistic. So what is spatial audio? It means when the BMW colleague is let's say in the front on the right side of me, then I hear it from this perspective, from this positional direction. Is he's in the back of me? I hear it from there. So it's like how we are talking in the real world. It's transferred into the VR. So just that you have an idea how you could use it in a gaming environment, for example, and in a VR or non-gaming environmental. And this said. I give to Philip. He's the CEO, and he can hopefully give a bit more details, technical details about this topic. So, Philip, the stage is yours.
Hi, thank you. Yeah, very nice meeting you. And I will share my screen to share some slides with you. I want to introduce with what we are talking about is in-game voice chat. So we don't want to have like a tool like Discord or WhatsApp or other tools that some gamers might use to talk with others within the game, but we really talk about in-game voice chats. And there are basically three different types of in-game voice chats. The first one is basic voice chat. This is what we are doing right now. We have full volume. The direction of audio sources does not make any difference or is not even there. And you typically use it for video conferencing, walkie-talkie, and phone conferences. So what we have been doing with teleconferencing all years long. The next thing is spatial voice chat or proximity-based voice chat. It's basically the same. Spatial is the English word for 3D space, and proximity is like taking account the distance to some things. But sometimes you hear spatial voice chat, sometimes it's called proximity voice chat, but it's literally the same idea and basically the same implementation. And the idea is, as Marco said, is that audio is really part of the 3D world, which is of course very useful in virtual reality or augmented reality, where you already have like this 3D space around you. And what we want to achieve is that if someone is talking from the left, then you should hear him from the left. And if he's going away from you, then the volume is going down. And you also have special effects like Doppler effects. And you sometimes you can take into account wind. When you have a lot of wind, then it's different. And there are a lot of things that you need to take into account if you really want to have very good spatial or proximity-based voice chat. And then we have the last one, which is the most complicated, and that's multi-room voice. So what we mean with that is that you combine spatial voice chat with the basic voice chat. If you have been recently, if you walk around, then you sometimes see people talking on the phone. So they talk with someone you cannot hear because that's like electronic voice, but you can hear the one who is standing nearby you and yelling into his phone. And this opens up very interesting use cases also for XR applications. Or games. I will come to that later. So these are the basic three types, and the implementation is like the basic voice chat is quite easy to implement. Spatial voice chat is harder to do, and doing both together is not that easy to do typically. This is where we as a service provider come in. So if we want to concentrate on the proximity spatial voice chat, I want to get a little bit into detail what exactly is is that. So the volume and the direction of a user depend on the relative position to yourself or to your virtual avatar. You can also do advanced audio features like audio occlusion. So if a wall stands between two people, then you might not hear him. Or if the wall is like made from paper or glass, the audio might be dampened, but you might still hear him. And so there are a lot of things that you can do. And therefore, voice really becomes an integral part of the environment. And it leads to a complete different level of immersion and making it also feel very natural. If you have VR glasses in your face, you typically don't want to fiddle around with an external voice chat tool like Discord, because you want to be part of the virtual world, or you want to experience what you're seeing here, which is like the whole thing of XR, and you don't want to fiddle around with other apps, and you also typically want to have audio as part of the world. And so voice really integrates into the experience. And one very important use case that we learned is that if you notice like Teams meetings or our meeting here, they are typically that one or maximum two people are talking and all the others are listening. So it's typically these video conferences or these basic voice chat tools, they are typically very exhausting. There are many studies out there. They came up during COVID pandemic, when they were thinking, or when they were trying to figure out why our whole day meetings with Meet or Teams, why are they so exhausting, when it's like fun sharing the same space with people, talking to them the whole day in like an office or on a conference. And the reason is that you always have to concentrate, when is my point to step in, and you always have to control everything, because all the people are viewing you or are seeing you while you're doing things. In real world, it's typically not the case. You can just like turn around, or you can walk 2 meters where you have some space for yourself. So it's not that much you're not that much in the spotlight. And another very important thing is that even if more people talk, this is typically not possible. So you have to use breakout rooms, and you cannot really have a good multi-user discussion, because the audio does not have any direction, and therefore the brain only gets a mixed, meshed together audio stuff, where the ear cannot really distinguish between the audio streams, because the ear is using 3D space and minor differences in the direction to distinguish, is that an important voice for me? Is that like the guy talking that I want to listen to, or is it the guy nearby that is like just talking to someone else, but I'm not interested into what they are talking? And the ear can filter these things out based on the direction of the voice, and therefore proximity chat also enables really good discussions in virtual spaces and more users talking at the same time. And this is like you can see that on the right side here. We have some marketing material. I can show you that quickly so that you get an idea what I mean. So we have here you can see, like with the audio visualization, that if these 3 guys are talking, those 2 guys will not hear anything what they are doing. And these guys here are like embedded in a room with walls. So what they are talking, although they are nearby, you will not hear them talking. But unless you walk into the room, then you will hear them. So that's very powerful, because more people can interact and talk to each other in the same physical space, which is like more immersive and makes more fun, and is not that exhaustive. And then we have like another visualization which showcase like the segmentation or the specialization of the virtual world. So here it's basically the same. You can walk around here and you only get grasps of what some people might be talking. And you can have more users interactively talk within the same space. And this opens up a whole different level of immersive experiences. This is like the basic idea or the advantages of proximity and spatial voice chat tools. Based on this example is that you can really do things like that the voice chat becomes part of the world. So you have like brick and concrete walls. People are talking there and you cannot hear them. If someone opens the door, you might hear them. You have voice that blends into the environmental sounds, like doors and vegetation and all of that. And voice also comes from the same direction. It's not the layer above. It's really part of the world. And one very interesting use case, and Mad Fingers for the game, they use it. They use team chat. So you have like radio, basic voice chat, like with phone or walkie-talkie style talking. But if I talk to my colleagues, my voice is leaked into the world. So an enemy might hear me while I'm talking to my colleagues. So it adds a complete new level of game design, because you really need to be careful as a player, when do I talk to my colleagues, because the opponents might hear me talking to my colleagues, and therefore I reveal my position for them, and this is really a very immersive experience and makes a whole new level of gaming actually. And if you think about it, it's now a little bit technical, so I will walk through that, but I think it's also important to understand the technical backgrounds. We have basically two types of architecture of how to do voice chat. You always have like the voice chat server, and that is actually a forwarding unit. So all microphone input is sent into the server, and the server sends this audio stream to all users connected to the same room, and those users will get back this audio stream as playback, and then like the sound system of the device will play back it like via headphones or the speakers or whatever is required. And to manage all that, you have this voice chat layer, and there's one solution that many of our competitors are using, and it's typically a quite easy approach to build yourself using standard libraries like WebRTC or so. So if you are a developer, you typically think that should not be hard to do. So you typically use the first way of doing it, and that is having that external voice chat layer. But if you want to have proximity voice chat, you need to constantly sync what is happening in the world with the voice chat layer. So you need to send the position of each player multiple times per second to the voice chat layer. The voice chat layer then calculates the volume and the balance for each of these audio sources, sends them back to the game engine. The game engine then needs to adjust or needs to make use of the data from the voice chat engine and reflect it in the game engine. So it has to adjust the volume and balance of each enemy or each part of the game engine. And that's a lot of babysitting. Your application needs to constantly sync everything. You can mess it up. It gets complicated very fast. And of course, if you just want to have full volume basic voice chat, that might be an approach. And most competitors that use this approach have been in the space of like basic voice chat tools like video conferencing. If you think of, there are some competitors like Agora, they are more into the mobile space. So they are like the base of many mobile applications that use voice. and then they thought, okay, we should also have a Unity or Unreal SDK, but that is typically only a very slim layer and doing very basic things and not really helping you building proximity voice chats. And another disadvantage is that all of this needs to be handled by the game engine, which costs performance, and which also can disrupt the voice chat if like the frames drop or something like that. So that's okay for very basic things, but it gets really messy if you want to build advanced proximity voice chat solutions. And the other approach is a deep game engine integration. So you have the basic thing, you have the same voice chat server sending around the audio packets, but you have the voice chat is an integral part of the game engine. So the microphone is easy because that's actually the game engine just captures the microphone and sends it to the server. But the playback component is very important because the playback is just an audio source than everything else in the game engine. In the game engine, if someone starts a car or something like that, then you have a sound, and that sound effect is placed on the car. And when the car is moving, then the sound effect moves with the car, and the player then hears the car moving from left to right or from right to left. And if you have a deep game engine integration, the basic idea is that also voice chat is like linked to the player's position, and the playback from the server is then put into this specific audio source, and it's like a dynamic audio source. It's not fixed, like you have it on your disk and is played, but it's coming from the network, but it's basically the same idea. And so you don't have to babysit that voice chat at all. Everything is handled by the game engine, and the voice chat system only makes sure that the packets the audio streams are captured and playbacked in the right format and right time and many other things. But you as a developer, you don't have to do anything apart from integrating the SDK, the software development kit, the plugin that we provide or that other deep game engine providers provide, and you make some that depends. You need to make some minor adjustments, but then you already have proximity voice chat. If you use advanced tools like vVice or Fmod, you can also use them. And then you have everything that the audio of voice is exactly the same as audio in your game as you have used it before. And that's a super advantage. One last step to the server architecture, just to give an idea how everything works. This is like the voice server. This is what I had in the previous slide, the blue things, the voice chat server. And if you think about, you have a game server A, and there are players connected in different teams. So these teams, they share and they connect to a room where only their team chat is going on, and all players are connected to the room world, to the world room where all audio from the whole world is like integrated. And then you have the second team, and this second team also has their own room. And this is like a very advanced way of doing it. So everyone is leaking their audio into the world, but they can also have full volume broadcast with their teammates. And if you think about team-based games with Discord, if someone changes the team, then you need to make sure that this guy is not in your channel anymore, because then he can listen what you're planning or doing. So you always need to babysit what is happening in Discord. If you have an in-game voice chat, then of course, if someone changes the team, the connections to the voice server are also adjusted accordingly. So that's super flexible and super easy to integrate. It also works with multiple game servers, hundreds of thousands of game servers, and hundreds of thousands of players segmented in various rooms, as we call them, or channels, as others name them. And that's the basic architecture. And what you also see is that the game server and the voice server are different types of things. you should never, if you think I can build it myself, you should never build the voice chat part into the game server, because then you always have like issues, because voice is very demanding in terms of bandwidth. And if you put that into the same server, then you get a lot of problems with audio drops, and if there is a tiny lag, then yeah, that doesn't work. Others have done that in the past, so the voice chat should always be a separate part of the networking experience. Just a quick reminder that yeah, we are doing Odin Voice, and Odin is a platform that is a deep game engine integration. We have SDKs for all major platforms. It's cross-platform compatible, and we have built-in audio occlusion and many other things. So if you are interested, then of course you get a free demo key. You can play around with it, and yeah.